Okay, now we got some application problems. I got 6 examples and then you got 1 problem on the assignment. Okay. A store selling very expensive items will, on February the 8th, sell any item for $50 less than the listed price. On any day in February, the store will give a 15% discount to any customer who can prove that he or she contributed to a local charity. Part A. Write a function where $50 off is applied first, followed by the 15% discount of the unknown price. B. Write a function where 15% discount is applied first, followed by $50 off of the unknown price. If an item, and then C. If an item actually costs $400, calculate the cost from each composition. Now here's how to set this up. You're going to have an A, a B, and a C. Okay. Now let's worry about part A. Unknown price. You're going to put P for price. Now you have a dollar amount taken off, which is, take your dollar amount first. $50 less. That would be minus 50. Okay. Now the percent off, that's a 15% off. You put a times in the front, and then you go off this side and you take 100%, and it's a discount, so that would be minus 15%. That'd be 85%. Now you need to make that into a decimal, okay? 0.85, and that's what you're timesing by. Okay, so they want the $50 off first, so you parenthesize the P minus 50, and that's all you do, that's it. Okay, now, part B, you write the same thing, take your P minus the 50 times 0.85. But this time they want the 15% discount first, which is the percent, so that then you parenthesize this, okay, that's it. C, if an item actually costs $400, calculate the cost from each composition. So, I'm going to write 0.85 times, and then I'm going to put 400 in for P minus 50. Now, I'll figure that out here in a bit. Now, right here for part B, I had the 0.85 times P, so times 400 again, and then the minus 50 outside. Okay, so all you really do is just putting 400 in there and 400 in there. Alright, so we do the parentheses first. That's going to be 350. Okay, so 85% of 350, 0.85 times 350 is $297.50. Okay, now you're going to multiply first. 0.85 times 400, 340, and then minus 50, that's 290. So as you can see, it does make a difference what they do first. Okay, as a consumer, the better deal would be to do the percent first, then followed by the minus 50, because I pay less. Okay, next problem. You make a purchase at a local hardware store, but what you bought is too big to take home in your car. For a small fee, you arrange to have the hardware store deliver your purchase for you. You pay for your purchase plus the sales tax plus the fee. The tax is 7% and the fee is $20. So part A, write a function where the $20 fee is applied first, followed by a 7% tax, price is unknown. Part B, write a function where the 7% tax is applied first, followed by a $20 fee, price is still unknown. And then on C, if an item actually costs $500, calculate the cost from each composition. So we have an A, a B, and a C. Okay, so put your P variable down. Now the money is what I add or subtract. The money's $20. A fee is added to your price. Okay. Now you're going to multiply by your percentage, but the percentage I need to take 100%, but a tax doesn't take away from the 100% of the price, it adds on to it. So got to know whether you're adding or subtracting. That's 107%. You move the decimal twice, and you're going to put a factor of 1.07. Okay? And on part B, you might as well write the same thing, because it's the same stuff happening. You just put the parentheses different. Okay, they want the $20 fee applied first, so on part A, so right here, that's all you do. And on part B, they want the 7% tax applied first, which would be the multiplication first. Okay, then you simply, on part C, you replace the P with 500. Okay, so 1.07 times 500 plus 20. And then 1.07 times 500 plus 20. So in this instance, we add first, that's 520. And then we find 107% of 520, which would give us $556.40. Okay, right here we apply the 7% first. So 1.07 times 500 gives me $535. Then we add the 20. That's going to be $555. So from a consumer, this is slightly less, so I'd want them to apply the tax first and then add the fee on. Okay, next example. A store is having a 12% off sale on everything they sell. You personally have a $10 off coupon on anything you buy. A, write a function where $10 coupon is applied first, followed by the 12% discount. Price is unknown. B, write a function where 12% discount is applied first, followed by the $10 coupon. Price is unknown. If an item actually costs $150, calculate the cost from each composition. Okay, so P is your price, and you have a percent, and you have a money taken off. Now, first to your money, it's a coupon, so now we're back to subtracting. So you'd subtract $10, then times. Now we do our percent, but we got to take 100% and take 12% off, meaning minus. It's 88%. So the P is multiplied by a factor of 0.88. And then B is going to have the same thing. We just position the parentheses differently. So on A, they want the $10 coupon first. And on B, they want the percent off applied first. Okay, then $150 goes in for my P's. So up here, 0.88 times, and then put 150 minus 10. And then on part C, we got 0.88 times P. It's going to be times 150, and then minus 10. So you subtract, you get 140, then you take 88% times 140, $132.20. 123.20. Okay, then here you're finding 88% of 150 first. It's 132 minus 10. That's going to be 122. So this is the better deal. Okay. You have two coupons. One is for $20 off your purchase price. One other is for 25% off your purchase price. Write a function where $20 off is applied first, followed by the 25% discount. Part B, write a function where 25% discount is applied first, followed by a $20 off of the unknown price. Then later on part C, if an item actually costs $250, calculate the cost from each composition. Okay, so P. First, let's talk the money, the actual dollars. $20 off is minus 20. Okay. Then times, you take 100%. Okay, 25% off means subtract. Remember, a tax means add, off, or discount, so subtraction. Okay, so 0.75. Then right here, okay, so on part A, they want the $20 off first. On part B, they want the 25% discount, that's where the 0.75 is at. Then you simply put $250 in for P in each composition. So you have on part A, you had 0.75 times parentheses, and then we're going to put 250 minus 20. Then on part B, we had 0.75 times P, which is going to be times 250, then minus 20 outside. So we simplify it, that's why the parentheses, so 230. So then I take 0.75 times 230, gives me $172.50. Okay, then in this instance, we find 75% of 250 at the beginning. And that's going to be $187.50. Then I subtract 20, and that's going to be $167.50. So as a consumer, we want them to do this first instead of that. Okay. I'm going to skip the next example and just go here. Okay. During a sale, music store is selling drum kits for 20% off. Preferred customers also receive 15% off. Write a function so that 15% off is applied first, followed by 20% off, price is unknown. Write a function so that 20% off is applied first, followed by 15% off, price is unknown. It says, what do you notice? Okay. So A, B, and C. Alright, so my P is my price. Now they're both percentages, okay? So they will be both times operations. There's no money I see, okay? Just put a times on each side. And then same on part B. Okay, so 20% off. Take 100% minus 20%. That's going to be 80%. So it's going to be 0.8 or 0.80, okay? You can put that, it doesn't matter where you put it because you're going to organize your parentheses. Then we also know that there's a 15% off. So 100 minus 15% is 85%. Okay, so 0.85. So it's all times. And then the same thing here. Okay, so they want the 15% off first, so that'd be my 85%, and then here they'd want the 80%. So, I'm going to give you a money amount to put in. Let's say $600. Okay, so 0.85 multiplied by 600, and then times 0.80. Then 0.85 times 600 times 0.80. You just shift the parentheses. So I find 85% of 600 first, 510. And then I take 510 times 0.80, which is $408. Okay, 600 times 0.80, that's going to be 480. And then I find 85% of 480. It says, what do you notice? That's the fact that they're the same. They are the same because it was all multiplication. Multiplication is commutative, meaning no matter what order you do it, it results in the same thing. So as a consumer, it doesn't really matter what percent is applied first when there's 2%.